Hey, in this video I'm going to show you how you can make 3D model in Revit using RhinoInside and simple parametric logic in order to place a large number of vertical wooden joists, binders and horizontal frames with far fewer clicks. If you place a large number of wooden joists and wooden elements the traditional way in Revit, it quickly becomes tedious. You end up clicking and adjusting each wooden part manually, and it is hard to see the bigger picture. You can speed things up by making nested families over repetitive design elements, like for instance here we have a door opening with a large window opening, and here is the same design element, door opening with a large window opening, and then we also have several groups with 2 windows in each group. You could make nested families for these repetitive design elements, but in that case you are limited by how those nested families are built. Using nested families can make exploring different layouts more tedious. I am going to focus only on one wall, that's this one. The wall is 25 meters. The wall is supposed to be prefabricated and then transported to the building place. Due to the transportation limits, each wall shouldn't exceed 8 meters. That's why we are going to divide the whole wall into 4 blocks. For instance, this block is 7.5 meters, the next block is 7.8 meters, then we have a block that is 4.2 meters, the last one is 4.37 meters. I can show you the production drawing for one of the blocks. In the legend you can see that everything is built using 4 simple families. One family for the vertical joist with a notch, and we need a notch in order to place the binders, and one family is vertical joist without the notch, and those we are going to place under the windows. Then we have one family for the binders and one family for the horizontal frames. There is nothing complex here, just clear, well-defined families. We will build the family for the vertical joist with a notch together. The other families follow the same logic and you can easily create them on your own. After that I'm going to show you the algorithm. The algorithm can be designed in many different ways, but I'm going to show you the approach that I found works the best. Let's go and create a family for the vertical joist with a notch. Go to File, a New, Family, English, Open, Metric Structural Column, Open, and my wooden joist is 45 by 170 millimeters, and go to Create, Extrusion, Rectangle, and draw a rectangle between the reference lines. Okay, go to the back view for instance, and let's see. I will align the upper part of the column with the upper reference level. First choose the upper reference level and then the upper part of the column and lock. And now I will go to the right view and I will place my notch. Go to Create, Void, Void Extrusion. I will draw a rectangle, something like this. We can adjust the dimensions now, and I will have 90 by 220, and now I will align this line with this reference plane and even this line that defines our void with the upper reference plane. I choose the upper reference plane and then I choose this line that defines our void and lock. Now I will choose this reference line and then this line that defines our void and lock. And now I will also place dimensions between the void lines and lock, and even here. Make sure that you choose the void lines and lock, and check. Go to 3D view, Let's adjust this void a little bit. And I will even check in here, cut with voids when loaded. And now I will go to right view, for instance, and I will create one reporting parameter that I'm going to call cutting length between the lower part of the column and the upper part of the column. And I will have it on the instance level, and I will call it cutting length reporting parameter. Okay. And I will define two more parameters. Go to family types, new parameter, and I will place those parameters under text parameters and identity data, also instance level, and I will call this one wall number. Okay, and one more parameter, instance level, and I will call it block number. And text identity data. Okay, here is the block number parameter, and here is the wall number parameter. Even though I'm not covering scheduling in this video, these identity parameters are important because they reflect how the wall is divided into prefabricated blocks. That's why I wanted to create them together with you. Okay, and now I will save this family. I will call it vertical joist, B for binder, let's say 90 by 220. Save. Now I'm going to switch to a clean model and see you in the next part. Thanks for watching.